Good morning. Less students there. Good morning. Good morning. Morning. Good morning. So voice and everything clear? Okay. So I started significant figure and all the rules I completed, I think. In the last I discussed change of unit will should not change the, when we are changing the unit, number of significant figures should not change. I think that was the last point I discussed. Yes or no? Okay. Now we will discuss the significant figure in the mathematical operation. Number one. In addition and subtraction, how we follow the rules for a significant figure. So one thing, addition and subtraction, if the number does not contain decimal, like suppose I am saying like this, then one number has 232, we can say it has the 2 significant figure, 54 has the 232 has the 3 significant figure, 54 has 2 significant figure. After adding what we will say, this is the 286. Okay, in addition when it does not contain decimal, whatever the addition we are getting, that is up to the correct significant figure, we can say. Reason is what, if suppose I am saying 232 has 3 significant figure, 54 has 2 significant figure. If you are writing the answer in a 2 significant figure, like later I will discuss the rule for multiplication and division, there we are taking minimum significant figure. If that rule we are following in the case of addition, so 232 3, 54 2 significant figure, so answer you will write in 2 significant figure. Then means you will say the after rounding off you will say 29. Is it meaningful? No. That's why in the addition directly whatever you are getting, when the number does not contain decimal, whatever you are getting, that is an answer with the correct significant figure, we can say. So that's why addition we will never discuss about this significant figure in this type of addition. Everybody getting or not? So whatever you are getting, that is a correct answer. Okay. After that, suppose they say the addition you have to write up to this significant figure, they will never ask like that. Okay, so here directly 286 is the answer with the correct significant figure. Okay, if the number does not contain decimal, then if the number contain decimal, then if the number contain decimal, then in the final result we will have as many decimal place which is equal to the minimum number of decimal place among all the number. Okay, again I am repeating, when the number contain decimal, then in addition and subtraction, first I am talking about addition and subtraction, when number contain decimal, then final result will have as many decimal place which is equal to minimum decimal place among all the number. Okay, it means there also we are not checking the significant figure, basically we are checking the decimal place. Okay, everybody got or not? So if the number contain decimal, so normal left of the decimal, whatever you are getting, that is right. Okay, right of the decimal, what you have to follow, which has the minimum significant figure, which number has the minimum decimal place, our result will also have the same number of decimal place. Okay, so what I said, in addition and subtraction, if the number contain decimal, then final result will have as many decimal place which is equal to minimum decimal place among all the numbers. Everybody got or not? So we have to, when addition, the decimal is there, then we have to check only decimal place in the case of addition and subtraction. Are everybody getting? So like suppose example I am saying, this you have to add, okay, 23.546 and 1.23. So you have to write the answer up to the correct significant figure, they will say, or following the rule of significant figure. Okay, so when you are adding, first we will do the normal addition. And one more thing, like suppose I have to write the answer up to the 1 decimal place. Suppose we have to write the answer up to the 1 decimal place. Always in the intermediate step, we will calculate 1 decimal place extra. Listen, what I'm saying, later, like in the case of the multiplication and division, when you have to find, like suppose 4 significant figure, answer should have, final result should have 4 significant figure, then we will calculate in intermediate step, we will find up to the 5 significant figure, and 5th one we will use by using round off. Okay, like you want 2 decimal place, then what we will do, we will write up to the 3, we will calculate up to the 3 decimal place. Okay, and the 3rd one we will replace by using round off. Okay, so here first we will do the addition. Now here this has the 3 decimal place, this has the 2 decimal place, this number has 3 decimal place, this number has 2 decimal place. So means our result should have 2 decimal place, because minimum is what, 2. Okay, now after adding 6, 7.24, left of the decimal, no need to see. Okay, now this result I write up to the 3 decimal place, but what we have to write, we have to write up to the 2 decimal place. So 3rd decimal place we have to remove. Okay, now we will use the round off. After removing, this is the more than 5, so preceding will increase by 1. Then what is the answer? 24.78. Completed. Okay, what is the answer? 5.8 plus 2, what is the answer? 7.8888. Now here you will see 5.8, it has 1 decimal place, and here I am writing 2 without any decimal place. Means in the 2, how many decimal places is there? 0. In 5.8, how many decimal places are there? 1. So 1 and 0, 2 decimal, we can say 1 and 0, which is minimum 0. Okay, so what I said, minimum decimal place we will write in the final result. Okay, so what is the decimal place in our final result? 0. Why? One has a 0 decimal place, one has a 1 decimal place, so we will write minimum. So first we will write up to 1 decimal place, then you will use a round off, then it is what? 7.8. But we don't have to write any decimal place according to the rule. Then round off means this you will remove, then you can write as what? 8. Everybody got? I say yes or no. Completed? Now next mathematical operation is what? Multiplication or division. So in multiplication and division, we are checking for the significant figure. So in multiplication or division, final result will have as many significant figure that is equal to the minimum number of significant figure among all the given numbers. Okay. Again, I am repeating, in the case of addition and subtraction, we are checking for the decimal place. We are taking minimum decimal place. But in multiplication and division, we are directly checking the significant figure. So final result will have as many significant figure which is equal to minimum significant figure among all the numbers. Everybody got or not? Sorry. Final result will have as many significant figure that is equal to minimum significant figure among all the given numbers. Okay, so what I said here, final result will have, in the case of the multiplication and division, the final result will have as many significant figure that is equal to minimum significant figure among all the given numbers. Okay. Here also, suppose you want 4 significant figure, in the final result should have 4 significant figures. So we will calculate up to the 5. Fifth one we will remove by using round off. Okay. Suppose length of the rectangle is 2.25 centimeter and breadth is the 1.4 centimeter. Then find area up to correct significant figure. Find area of rectangle up to correct significant figure. Tell fast. Find area up to correct significant figure. So length has how many significant figure? 3 significant figure. Okay. Breadth has how many significant figure? 2 significant figure. Then area will have how many? Area will have how many significant figure? 2 significant figure, because minimum is what? 2. So 2.25. What is the product you are getting? By multiplying, you will get what? A is equal to 3.15. 3.15 centimeter square. But you have to write up to the 2. You have to write up to the 2 significant figure. So then this 5 you have to drop. Now 5 you have to drop. Then what I said, we have to check the preceding digit. If it is a odd, it will increase by 1. If it is a even, it will remain unchanged. So like here, I have to draw 5. Now preceding is what? 1. 1 is the odd. Then what is the area? I will write 3.2 centimeter square. Completed. Same like density problem has given in the NCERT. In the NEET also they asked that question. Means density is the mass by volume. Suppose mass has 3 significant figure, volume has 2 significant figure. So final result or density will have how many? 2 significant figure. Okay, one is solved example is there in the NCERT, 5.74, and they given mass and volume 1.2. So means 3.74, 5.74 means 3 significant figure. Volume 1.2 means 2 significant figure. So density will have 2 significant figure. Completed. Another problem. Suppose I am saying radius of the circle is 1.25 centimeter, then we have to find the diameter of the circle and area of the circle with correct significant figure. Now diameter and radius relation, what we know? D is equal to 2R. D is equal to 2R. Then D what I can say 2 into R. R what I gave 1.25. So 2 has how many significant figure? This 2 has how many significant figure? So here one number is the 2, one number is the 1.25. So 2 has how many significant figure? One, okay. So a small example I will give. Who is saying the answer 1? Suppose I'm saying radius of the earth is 6,432 kilometer. Okay, radius of the earth is 6,432 kilometer. Now what is the diameter of the earth? So diameter of the earth you will say 2 into R. Suppose I am asking up to the correct significant figure, you have to write diameter of the earth. Okay, so diameter is equal to 2 into R. Then you will do what? 2 into 6, 4, 3, 2. Then what you will get? 2 to the 4, 3 to the 6, 2, 4 the 8 and 12. Okay, this you are getting. Now according to the rule of the significant figure, answer you have to write to the minimum number of significant figure. So 2 has 1 significant figure according to you, and the radius has 4. So 1 has 1, 1 has 4. So final result will have 1. So after that you will say what? 1 kilometer. According to the what you are saying that 2 has a 1 significant figure. So if we are following the right significant figure here, so radius is the 6432 kilometer, diameter is 1 kilometer. Okay, so is it meaningful? Is it meaningful? No. Okay, it means here this I cannot say the 1, something wrong. Okay, are everybody getting or not? So listen, exact number that is not a measurement. Exact number, that is because in the beginning when I started the significant figure, one thing I said, significant figure we are learning for the experimental data, measurement or any physical quantity. Okay, so it is not for the pure number. Okay, so when like 2 here 2, this 2 is what? The diameter is a 2 times of radius. 2 times of radius. This 2 is not any measurement, not any experimental data. Okay, not any physical quantity. It is representing only the exact number. Okay, so when you have the exact number, it is not the measurement. Then it can have, we cannot say always infinite, but it can have infinite significant figure. According to that you can increase, means it can go up to the infinite. So means 2 here, 2 is the what? It is not the measurement, it is the exact number. 2 times, 10 times, 20 times, 30 times, that we are not measuring in the lab. That is a what? Exact number. So they can have infinite significant figure. They can have infinite significant figure. Like suppose I am saying your NEET marks increase by 2 times. Your NEET marks increase by 2 times. Reverse happen, but suppose NEET marks increase by 2 times. Then 2 times I can write as a 2 times, or I can write as a 2.0 times, or I can write 2.00 times. Means ultimately here there is a these zero, any number of zeros I can put. It will not say about the precision of the instrument, like I am using the meter scale, I am using the vernier calipers, I am using the screw gauge. So that's why we can put any number of zeros. So according to the rule of significant figure, we can say we can write up to the infinite zero. Okay, so when there is an exact number, then what is the number of significant figure we can take? Infinite. Okay, everybody getting or not? So this 2 can have the infinite significant figure, and 1.25 has 3 significant figure. Then final result will have how many significant figure? Infinite and 3. What is the minimum? 3. Then diameter will have 3 significant figures. So what is the diameter I can write? 2.5, but we have to write up to the 3 significant figures, so 2.50 centimeter. Are everybody got or not? So what I said, exact number 2.50 we will write because up to the correct significant figure, because when the number contain decimal, all trailing zeros are the significant. That's why we can write up to the 2.50. This everybody got? Okay. Diameter clear? Now area how we can find? Area we will use what? Pi r square. Pi r square means pi into r is what? 1.25 into 1.25. Pi has how many significant figure? Pi has how many significant figure? Pi has how many significant figure? Tell fast. I expected that answer. One answer I got 3. Again the same thing. Pi we are not measuring, na? Pi we are not measuring. Pi is also the exact number. It is also not the measurement. Okay, so pi can also have infinite significant figure. And maybe who is saying the 3? They are thinking 3.14. 3.14. We are writing the one approximate value. And even maybe in the class 9th or 10th you have learned pi is the irrational number. So you are saying the pi is a 22/7, but pi is not a 22/7. 22/7 is the nearest rational number of pi. Okay, even 22/7 if you start dividing and start calculating up to the 12th or 13th digit, you will get the remainder 0. It will get completely remainder 0. But pi, it will go up to the infinity. So by the value of the pi also, we can say it has an infinite significant figure. And by the concept what I said, if it is not a measurement, it is a number, exact number, then it can have infinite significant figure. So pi can have infinite significant figure. Okay, then here 3, here 3. So final result will have how many? So pi value you will put 3.14 for the calculation. But significant figure we can take as a infinite. Everybody got or not? To find the value, pi we can take as a 3.14 into 1.25 into 1.25. And you will find up to the 3 significant figure. Understood or not? Calculation you will do. Completed? Anybody will say the answer? 4.91. Sure? 1.56. Wow. 4.91, 1.56. What I have to write? .91 we can say. Okay. Centimeter square. Okay then. So this completed. So if you want, then you can write as a arena, like how you are getting 1.56. Pi also you have to multiply, na? So you can write one note if you want. Means exact number that is not, if it is not a measurement. Exact number, if it is not a measurement, it can have infinite significant figure. It can have infinite significant figure. Okay. So exact number that is not a measurement can have infinite significant figure. Okay, like suppose I am saying I have one ball whose mass is 2.5 kg. I have one ball whose mass is 2.5 kg. What is the mass of such identical 5 balls? What is the total mass of identical 5 ball? So what I said, I have one ball, mass is what? 2.5 kg. So what is the mass of such 5 ball? So how many significant figure will be there in your final result? So 2.5 kg mass of each ball. So what is the number of significant figure? 2. 2.5 number of significant figure 2. I am saying mass of such 5 ball. So that 5 is exact number. That 5 is exact number. It is not the measurement. Okay. Then that 5 we can have. It can have infinite significant figure. So final result will have how many significant figure? 2. Understood or not? So when exact number, it is not the data, not the measurement, then we can say it can have infinite significant figure. Okay. Like suppose I am saying 8 kg. 8 kg has how many significant figure? 1, because it is a measurement. So 8 kg is what? 1 significant figure. But number 8, if I am taking pure number, then number 8 times I am saying, then what is the number of significant figure 8 can have? We can say it can have infinite. Understood or not? Completed? Okay. Now, error, that is the important topic of this chapter. So one thing, what is the error? Who will say what is the error? Like error means what? So error, error is the, like you are saying, error is the mistake. Error is the mistake. Okay. So error, one thing, error is not a mistake. Error is not a mistake. Basically, error, we can say error in the measurement. We can say it is the deviation from the true value of the quantity. When we are doing the experiment, we are very careful. Everything we are following properly. But maybe experimental condition, maybe instrument, maybe some problem, I am getting some deviation from the true value. I am getting the deviation from the true value. So that deviation from the true value, that is called the error. That is called the error. Okay. Like one example I gave. Last class, like this, any thread length you are measuring, then what you will say in this case, what is the length you will say? Somebody said, sir, 2.2. Somebody said, sir, it is a 2.3. Are you remember or not? Okay. So here, what I said, like when you are measuring any length, so it is reaching to the 3 and crossing the 2, but not reach to the 3. So somebody said last class, I asked this, then somebody said 2.2, somebody said 2.3. Okay. So here, who is saying 2.2, who is saying 2.3, both are the correct. That is not your error. Reason is what? We don't have the, that instrument which can measure exactly. So I have the normal scale. I have normal scale. Its least count is what? 0.1 centimeter. So either I can say 2.1, 2.2, or I can say 2.3. Okay. Suppose this exact wire length is the 2.26. Exact wire length is the, I measure by using vernier calipers or any device. Exact length is the 2.26 centimeter. But by using I am using the normal scale, meter scale, then either I will say 2.2 or I will say 2.3. So in my result, some deviation is there from the true value. If I am saying 2.26 exact and I am saying 2.2, so what is the error in my measurement? 0.06. Who is saying 2.3 and exact value is 2.26, then what is the error? 0.04. So that is the error from, because my instrument does not have a limit, means it can measure the decimal 2 place because I am using the normal scale. So it is not my mistake. Getting or not? So basically what is the error? It is a deviation from the true value. Everybody got or not? Okay, and why we are not that much perfect in the measurement, then why we are learning the error, why there is a need to discuss the error. Okay, so error is what, basically why we are learning the error. Reason is what, there is an importance of the error. If you know the error, that in any quantity how much error maximum I can do. Suppose one small example, like suppose you want to launch the satellite from the earth to the moon, and you calculated the distance between earth and moon. Okay, so which method you will use? Parallax method you will use to find the distance between earth and moon. Okay, by the method, suppose you got the distance is 20,000 kilometer, distance between the earth and moon, you got the 20,000 kilometers, suppose. Okay, by the parallax method, so you are using the rocket and to launching the satellite, and the rocket, how much distance it will travel in a 1 kg of fuel. Suppose 1 kg fuel it will consume for 1 kilometer. So you will put 20,000 kg fuel. Okay. If it is possible that when you launch the rocket or satellite will not reach to the moon, before that fuel will get over. Why? Because in my method, maybe I use the parallax method to find the distance between earth and moon. In my method, some error may be there. Some error is there because maybe approximation we have taken, and some error is there. If I am not considering that, then what will happen? I am taking exact, then maybe it is possible that my rocket cannot reach to the moon. Okay, suppose we know that in that method what I am using to find the distance between earth and moon, in my method maximum error can have 100 kilometer, maximum error can be 100 kilometer. Okay, means maybe it is a more than 20,000, 100 kilometer, more than 20,000 or less than, but I know that maximum error in this method is the 100 kilometer. Then what I will do, I will put the 100 kg fuel extra, 100 kg fuel extra, because maximum error what we can have 100 kilometer. Then what will happen? Then sure we can say surely our satellite will reach to the moon because extra fuel we have put there. Okay, so that's why there is the importance of the error, and due to this reason, in even the problem they will not mention, they will ask the error in the measurement, but always we are calculating the maximum possible error. Sometimes they will mention, like it depends upon the examiner, they said what is the maximum possible error in this quantity, then it is okay. Even they are not mentioning, then also we will always calculate the maximum possible error in the measurement. Everybody getting or not? Because minimum error is what? Minimum error is a 0. Okay, so in any calculation if they are asking the error, so basically what is the meaning of that? We have to calculate the maximum possible error. Okay, everybody got? Okay, now listen. To find the error, we should know what is the true value of the quantity. To find the error, we have to know the true value of the quantity. Okay, like suppose I am doing the simple pendulum experiment to determine the value of G at any place. Okay, and I know that this place G value is the 9.8. At this place G value is the 9.8, and I am determining the G value by using the simple pendulum. So when you will release the pendulum, you will find the time, and suppose you are getting the 9.6. By the calculation you are getting the G value 9.6. So here true value is 9.8, but by the experiment I am getting the 9.6. So how much error in my measurement has? 0.2 meter per second square. Okay, so to get the error we should know the true value. We should know the true value or absolute value of the quantity. Okay, everybody getting or not? So true value or the absolute value is what? True value or absolute value of the quantity is what? Exact value of the quantity. Okay, this everybody got? So what is the meaning of true value? Means what is the exact value of the quantity that we can say as a true value or absolute value. Okay, sometime in the problem they will give the true value. Okay, but sometime they will not give. They will give the observations are like this. So suppose I am saying any quantity A Suppose what I'm saying, any quantity A we are determining in the lab, and experimentally we are determining, and we have taken the n observations, and observation values I said A1, A2, and dot 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 AN. Okay, these different observation I have written. Maybe when you went in the lab, physics lab, chemistry lab, maybe you remember when you were doing the experiment, always the lab teacher was saying, lab assistant was saying, take the 2-3 reading, take the more reading, and then take average of all. Okay, why they were saying this? So suppose in the any problem, in the any numerical problem, they have not given the true value, then their mean of all observation, we can consider as a, it will be close to the true value. So we can consider, we can take them as a true value. Again I am repeating, if in the problem true value has not given, then they have given the observations. So to calculate the error and all, what we can do, average of all, mean of all observation, it will be closer to the best possible value of the quantity. It is the best possible value of the quantity. So mean of all observation will be the best possible value of the quantity, or we can take as a true value of the quantity. Why we are saying the average will be the best value? So if you think, suppose you are doing the experiment of simple pendulum and determine the value of G. So you release the pendulum. As you release the pendulum, you start your stopwatch. Okay, most of you have done the practical of the simple pendulum. You release your pendulum and release the stopwatch. Stopwatch started. Suppose you have to measure the time for 20 oscillation. Okay, when you release the pendulum, it is started. Okay, now you are just counting. When it is going to complete 20 oscillation, you are very conscious, you stop. So before completing 20 oscillation, you stop. Okay, then next observation, what will happen? Suppose now you write down the reading of the time. Okay, next observation, what you will do? Next time, you know that earlier in this observation I stop early, little before I stop. Then suppose you release the pendulum again, your stopwatch started. Okay, then what will happen when it will complete 20 oscillation? After that you will stop, because last time you know that I stop early, so you will be more conscious this time, so you will stop after completing 20. So like first observation, you can think you have measure lesser, and second observation you have measure more. So like this way, when you will do the experiment and you will take the average of all, so you will be very close to the true value. That's why mean value, we can say the best possible value of the quantity. Everybody got or not? So in the problem, if true value not given, then mean of all observation we can say as a true, we can take as a true value. Okay, then here mean value, what I can say, A1 plus A2 means that is a basically arithmetic mean, AN by N. So mean value of all observation, what we can say, A1 plus A2 plus AN by N. Completed. So what I said, if the true value given, then it is okay. Otherwise, whatever we are getting here, that we will take as a true value. Okay. Then next thing, absolute error. So what is the absolute error? It is the magnitude of difference of true value and observed value. So one thing, what? Absolute error will always be positive. Absolute error will always be positive, because what I have written here, that question also maybe in the theoretical question they can ask which statement is correct about the absolute error, or assertion reason they can say. It is the magnitude of the difference of the true value and the observed value. Okay, like which is more, which is less, doesn't matter. Ultimately for the absolute error means what? If suppose I am getting the G value by the experiment 9.6 and true value of the G at this place is 9.8. So what is the absolute error? You will think, sir, I have to take 9.8 minus 9.6 or 9.6 minus 9.8. No, absolute error means whatever the difference, that magnitude you have to take. So what is absolute error? 0.2. Everybody getting or not? So what is the definition I write? It is the magnitude of the difference of the true value and the observed value. Okay. Got? Okay. So if suppose I am saying absolute error in first observation. What is absolute error in first observation? So first observation is what? A1. What is the true value I am taking? A. First observation is A1, true value is the A. So what is the absolute error in the first observation? Mod of A minus A1. Okay. From which is more, from that you will subtract. Otherwise what I am saying, whatever you are getting, its magnitude you have to take. Magnitude means always it will be positive. So absolute error in the first observation is what? A minus A1. That I am writing as a delta A1. Similarly, second observation, what I can write? Delta A2. That will be equal to what? Mod of A minus A2. Like this, I can find the absolute error in all observation. Okay. Then what is the mean absolute error? That is a delta AM. Delta AM will be equal to what? Delta A1 plus delta A2 plus dot 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 delta AN by N. Same like how you calculate the mean value, same way we can calculate the mean absolute error. Okay. Completed. Okay. Now with the error, how we write the quantity? Like suppose you know the error and you know the like true value of the quantity, then how we write the quantity with the error? One thing, when we are doing the experiment to find any quantity, so we don't know, suppose I don't know the value of the quantity, so we don't know whatever we measure, maybe I measure more than actual or maybe I measure less than actual. Okay, you have done the some experiment, you have taken the n observations and by the observation you got the some value, okay, that you are taking as a true value, but that value you don't know it is a more than actual or it is a less than actual. That's why error we always write like this way. Suppose quantity A you are writing, so we write as a plus minus or A plus minus A mean or plus minus delta A. Okay, means A we can take as a true value, A we can take as a true value and this we can take as a error. Why we are writing plus minus? Why we are writing as a plus minus? Because it is possible that value may be, I am measuring more than actual, then A plus delta A. I am measuring less than actual, then A minus delta A. That's why error we are writing like a plus minus. Somebody can think, sir, you said always we are calculating the maximum possible error. So always we have to do A plus delta A. I'm not saying this error. Means here this error you will always calculate maximum. This delta A we will always calculate maximum possible error. But quantity what you can write either more than actual or less than actual. So that's why this error we are adding or subtracting. It is a maximum possible error we have to calculate. Getting my point or not? But how you will write the quantity with the error? A plus minus delta A. Why plus minus delta A? Because we can measure the more than actual or we can measure the less than actual. Okay. Completed. Okay, so one small problem. Suppose time period of simple pendulum, we are measuring 1.46 second, 1.54 second and 1.62 second. Three measurement I have given by any device. Like one thing we know that here we are not using the wristwatch, because wristwatch can measure 1, 2, 3, 4, 5, 6. Okay. We are not using the stopwatch. Why? Because the stopwatch can measure 0.1 second minimum. So maybe any device we are using that can measure the decimal 2 place. Then time three values I gave, three observation I gave. I am asking what is the mean value up to the correct significant figure. So mean value of the time period I can say that is the what? 1.46 plus 1.54 plus 1.62 by 3. Okay. I gave the difference of the 3 in all. So I 8 in all. So directly middle one will be the average. Directly you can say 1.54 second. I think everybody is getting. Now listen. If suppose they want to check, I said according to the rule of the significant figure decimal place, that is correct. Okay. Maybe all options are like this: 1.54, 1.52, 1.58, like this. Then you can say 1.54. But if we are following the correct significant figure, then it is wrong. If you remember the definition of the significant figure, I said it is the total number of, it is a sum of all certain digit plus one uncertain digit. Every calculation, who is saying 1.54, that is okay. Now listen what we have to do. Suppose that option also there, and if they are asking the correct significant figure. Okay, why this is incorrect? Because I said the definition is what? Significant figure is the total number of the certain digit plus one uncertain digit, plus one uncertain. Means any measurement finally we cannot write more than one. Finally we cannot write more than one uncertain digit. Means uncertain can be any, but uncertain has to be one. That is the definition of the significant figure. Okay. If you see this data, so in the data 1.46, 1.54, 1.62 are there. Okay. If you see decimal first place is certain in the measurement. In all measurement what I gave, decimal first place is certain. All measurement what I gave in this time what I gave the time 3 values, for decimal first place is certain. Same simple pendulum, I am measuring the time period, decimal first place is certain. Are you say yes or no? So if you see decimal first place, no. Decimal first place in the first measurement it is a 4. Decimal first place in the second measurement is 5. Decimal first place in the third measurement is what? 6. It means decimal first place is not certain. Then how we can write up to the 2 decimal places? That definitely decimal second place is also uncertain. Means in this result 1.54 when I am writing, so how many uncertain digits are here? In this, how many uncertain digit is here? 2 uncertain. Why? In the data decimal first place is not certain, then how it can be the second? So both decimal place is uncertain. So maximum uncertainty I can write 1 only. So that's why what is the result? After that I will use a round off and then I will write the result is what? 1.5 second. This everybody got or not? Because maximum uncertainty what? We can write 1 uncertain digit only. Suppose this question I gave 1.56, 1.54, 1.52, 1.56, 1.54, 1.52. Now by seeing the data you can see the decimal first place is certain, 1.56, 1.54, 1.52. So decimal first place is certain, then I can write the answer up to the 2 decimal places. But here after seeing the data, here decimal first place is uncertain, then how we can say the decimal second place? Everybody got or not? Understood? Okay? Okay then. One small problem for the practice, you can write more. If G value measured nine point six, 9.9, 9.8 meter per second square, find mean absolute error if G value, very simple problem, at that place is 9.8 meter per second square. Tell fast. Zero point 0.1. So here, like if I am saying the absolute error in the first measurement, so delta G1, I can say what? Mod of like magnitude we have to write. So then we can say what? 9.6, 9.8 difference, what you will get? 0.2. Delta G2, what I can write? 9.8 minus 9.9, that is equal to 0.1. And delta G3, what I can say? 0. Then what is the mean absolute error? Delta GM is equal to 0.2 plus 0.1 plus 0 by 3. Then what you will get? 0.1 meter per second square. Okay. Completed. Okay, now error in mathematical operations. Number 1, addition or subtraction. So in the addition and subtraction, how we are finding the error? Okay, so in the addition, whether you are adding the quantity or you are subtracting the quantity, error we are always adding. Error we are always adding. What I said, because we are always calculating the maximum possible error. So whether we are adding quantity or subtracting the quantity, error we will always add. Okay. We can say in addition or subtraction. So in addition and subtraction, we are always error always added. Okay, everybody got? Completed? Okay, so in addition or subtraction, error we are always adding. Okay, because we are always calculating maximum possible error. Okay. Now, example we can do now. Suppose I am saying that temperature of, this is a similar example given in NCERT, temperature of two, okay, one more thing first. So like suppose I am saying A and B are two, A and B are two values or two quantity with error delta A and delta B. So if I am saying the A and B are the two quantities, A is what? A I can write as a plus minus delta A, and B I can write as a B plus minus delta B. Now we can define the addition and subtraction. So in summation, sum S, what I can write? Sum S is equal to A plus B. Sum S, what we can write? A plus B. If I am saying what is the error? So error in S, that we will write as what? Delta S. What I said, error in the A is what? Delta A. Error in the B is what? Delta B. Then what we will write here? Delta A plus delta B. So error we are always adding, whether we are adding the quantity or subtracting the quantity, error we are always adding. So sum S I can say A plus B, then error in S I can say delta A plus delta B. If I am defining the difference, so difference what I can say? That I am defining as a D. So D, suppose I am taking A minus B. Okay. This will give like true when you are taking, when I am writing A plus minus delta A plus minus delta A, then A we are taking as true value, delta A we are taking as an error. Suppose I need summation. Okay, so summation true value how you will get? By taking the true value of A and true value of B. So S I can say what? A plus B. S I can say true value of S is the A plus B. Error how you will calculate? Delta S is equal to delta A plus delta B. Similarly, difference how I am defining? Difference is the A minus B, suppose I define. Okay, so D is equal to A minus B. It will give the true value of D. How I will calculate the error in D? So error in D I can say, that is what? Delta D. This we will write as delta A plus delta B. Everybody got or not? So in both cases, whether you are adding the quantity or you are subtracting the quantity, error we will always add. Understood or not? Okay. Why we are doing this? Why we are always adding the error? So one thing I said, we are always calculating maximum possible, we are always calculating maximum possible error. Okay. So one small example I will show. Suppose I am saying, saying any number, any quantity I am writing, 2.5 plus minus 0.2. Okay. And one quantity I am writing 1.5 plus minus 0.1. Okay, one quantity I am defining what? 2.5 plus minus 0.2, and another quantity I am defining 1.5 plus minus 0.1. Okay, now suppose here I need addition of the quantity. I am adding the quantity, both quantity A and B. So A what I gave 2.5, B what I gave, true value is the 1.5. If I am doing the addition means then I can say true value of addition S is equal to what? 2.5 plus 1.5. That what I will get? 4. Okay. This everybody got or not? If I am adding the quantity, suppose I gave one value is the 2.5, one value I gave the 1.5, then what is the true value of the summation? 2.5 plus 1.5, that is a 4.0. Why I am saying that error we are always adding? Suppose I am measuring, I don't know, I measure the first quantity. Suppose first quantity I gave A, and this is the what? B. I don't know A I measure more than actual or A I measure less than actual. Okay. Suppose I am measuring the A more than actual. A I am measuring more than actual. Then what is the A I will measure? Maximum 2.5 plus 0.2, that is a 2.7. Okay. So maximum A what I can measure? 2.7. Okay. Suppose B maximum, what I can measure? 1.5 plus 0. Because what I said, why we are writing the plus minus? Because we don't know we measure more than actual or less than actual. So suppose I am saying A, I measure more than actual, so 0.2, then A, what I will take? 2.7. B, I measure more than actual, then what is the B value I will take? 1.6. Okay. If I will add both, what I will get? I will get 4.3. Now what is the true value of the quantity? 4. But what is the addition? What is the addition I am getting? 4.3. Means what is the maximum error I can do? 0.3. Okay, so that's why what we don't know which quantity we measure the more than actual, less than actual. So that's why we are always calculating the maximum possible error. Same, suppose you are doing for the subtraction. Okay, in subtraction, when you will subtract, then what is the difference you will write? Difference you will write D is equal to what? 2.5 minus 1.5. 2.5 minus 1.5 is what? 1. Difference you got 1. Are everybody getting or not? Suppose I am subtracting, so difference what I got? 1. Okay. Now suppose I am saying I don't know, I have taken the A more than actual or B more than actual. Suppose I have taken the A more than actual and B I have taken less than actual. A I have taken more than actual and B I have taken less than actual. So what is the A value I will take? A value I will say 2.7. A I have taken more than actual, so A value what we will take? 2.7. B I measure less than actual. B I measure less than actual. Then 1.5 minus 0.1, what you will get? 1.4. Okay. Now A value this you have taken, B value this you have taken. If you subtract it, what you will get? This is the 3, this is the 1. So 1.3. So in that case, difference what you are getting? 1.3. What is the true value of the difference? 1. What is the error you are getting? 0.3. Okay, so that's why what I said, whether we are adding or subtracting, always we are calculating the maximum possible error. So it is possible that at subtraction also we can get the error is what? 0.3. And what is that 0.3? Summation of error 0.2 and 0.1. Okay, so always whether we are adding or subtracting, we are calculating the maximum possible error. Understood or not? Up to this completed? Okay. Now suppose I am saying here, what is a fractional error? Because sometimes they ask the fractional error or percentage error. So fractional error means what? Fractional error in summation. So fractional error, fractional change, whole physics we will discuss so many places. Okay. So change or error means what? Fractional error means error upon original or true value. That is the meaning of the fractional error. Error is what? Delta S upon true value S. This is the fractional error. Okay. If I am saying fractional error in the difference, so delta D by D. Delta D by D, that is a fractional error. If I am asking the percentage error, so percentage error means that we will say what? We will multiply this by 100. Okay. So fractional error is the error by true value and the percentage error is what? Error by true value into 100. That will be the percentage error. Completed? Okay. Suppose I have given the two body temperature with the error. I am asking what is the percentage error in the temperature difference of bodies. What is the percentage error in temperature difference of bodies? Tell fast. One body temperature 4.5 degrees C plus minus 0.2 degrees C. Second body 1.5 degrees C plus minus 0.1 degrees C. What is the percentage error in the temperature difference of bodies? Who is getting 5%? Nalayak. I think 10% will come. Temperature difference I am asking, not the addition. Who is calculating the 5%? They are calculating the addition. Everybody got 10%. Why? I am asking the temperature difference. So difference, suppose I am writing as a theta. That theta I can say what? Theta 1 minus theta 2. So true value how I will get? 4.5 minus 1.5, that is equal to 3 degrees C. So true value I got 3 degrees C. Okay. Now error how I will calculate? Error means delta theta. This delta theta is not the temperature difference. Okay. Theta I write as a difference. So delta theta is what? Error in the difference. Error in the difference. So then error I will directly add 0.2 plus 0.1. It is equal to what? 0.3 degrees C. Now what is the percentage error? Percentage error I can say what? Error is what? 0.3 upon true value 3 into 100. Then how much you will get? 10%. Completed. Later again some problem I will discuss in addition, but first I am completing the multiplication and division. Completed. Now next operation is what? So addition and subtraction one rule, multiplication division one rule for both significant figure as well as error. Okay. Now listen, in multiplication and division, what we are doing? So one thing, remember that in addition and subtraction, we can find error directly. We can find error directly means what we have to do? We have to add the error. Okay, in case of the addition and subtraction. In multiplication division, we will not remember the formula. We cannot even, because different complicated cases will be also there that you cannot mug up the formula. So in the case of the multiplication and division, we will learn the formula of the fractional error. We will learn the formula of the fractional error. So when any quantity depends upon the product or the division of the different quantities, so in that case, first we will write the fractional error. First we will write fractional error. After getting the fractional error, then easily we can get the error by cross multiplying the quantity. Again, I am repeating, when any physical quantity, any quantity depends upon the product or the division of different quantities. So in that case, first we will calculate the fractional error. First we will calculate the fractional error. After getting the fractional error, if they are asking the fractional error, percentage error, then directly you can find. Mostly they will ask that only. But if they are asking the error, then we have to do the cross multiplication. We will get the error also. Everybody got or not? So in that case, we will not remember the formula for error. We will learn the formula for the fractional error. In which case, in multiplication and division. Okay. So like one example I'm giving. Suppose X I write as A into B. X I am writing as A into B. It is a product. Okay. I want to find the fractional error or error in the X. Okay. So here A plus minus A. Plus minus delta A, B we can write as a B plus minus delta B. Means error in A is the delta A, error in B is the delta B. I want to find the error in X. Okay. What is the X? X is the product of A and B. Now, error, we are not doing like error 200%, 300%. Okay. This is not the error. That is a blunder. So error means always error is small. Error will be small. And for a small quantity delta, we can write as a D. Delta X we can write as a dx. Okay. So to calculate the or to get the error formula, what I am doing, I am differentiating both sides. Okay. If I am differentiating both sides, so differentiation of x, what you will say? Differentiation of x is the dx. And one more thing, mostly you are doing that like y is equal to x some function and dy by dx you are finding. When I am saying differentiation, it means I have not mentioned with respect to which. So like directly you have to write left hand side. Don't say the x differentiation is the one, because I have not mentioned you have to differentiate with respect to x. So differentiation of x dx, differentiation of x dx. Okay. Now right hand side we will use the product rule. Product rule, because two functions are there, a and b. So what is the product rule? First function into second differentiation plus second function into first differentiation. Then we got dx is equal to a db plus b da. Okay, by the differentiation I got. Now error will be always small, we can say. Then d I can replace by delta also. D I can replace by delta. Then I can write what? Delta x is equal to what? A delta b plus b delta a. Okay, this everybody got or not? So somebody can think, sir, I can mug up this formula. It is easy. I will get the error directly. Delta x is the a delta b plus b delta a. But here I gave the two quantities. Suppose you have the three quantity, more than three quantities. Some quantity are in the denominator. Okay, some powers are there. Those even you cannot differentiate also. So that's why what I said, we will not mug up the formula for error. Okay, because in that case it is simple, like two quantity are there and power is 1. But in some cases more quantity will be there, power will be different. Then in those cases we cannot differentiate easily. That's why we will not remember the formula for error in the case of multiplication and division. Then what we will do? This you have the delta x, this you have the x. So suppose I am asking the fractional error in x. So fractional error in the x, I can say what? That is what? Delta x by x. If you find the delta x by x, this is a suppose 1, this is the 2. Delta x by x, what you will get? A delta b plus b delta a upon x. What is the x? X is the ab. Now after dividing, what I got? Delta x by x is equal to what? Delta a by a plus delta b by b. Okay, like this relation you will get. So what is the delta x by x? Delta x by x is the fractional error in x. Delta a by a, fractional error in a. Delta b by b, fractional error in b. Okay, so this is what? Fractional error in b. So this everybody got or not? Now you calculated the fractional error. In other cases also, suppose three quantity are there. So three quantity differentiation is difficult, but I can say like ABC, x is equal to ABC. So delta x by x is the delta a by a plus delta b by b plus delta c by c. Okay. But suppose I am asking what is the error? So error means delta x. Error means delta x. So delta x, how I can calculate? Cross multiply the x, you will get the value. Okay. How I can find the x? By the true value of ABC. So x is equal to ABC, that I can find by the given true values. Okay. So if I need the error, after calculating the fractional error, cross multiply, you will get the error. Understood or not? Everybody got? If percentage error required, then into 100, into 100, into 100. Okay. Okay. So similarly, suppose I am saying x is equal to a by b. X is equal to a by b. How you will calculate the error? Okay. So what I said, whether like addition, subtraction, multiplication, division, we are always calculating the maximum possible error. Here b is in the denominator, but we will calculate the maximum possible error. Then what we will get? We will write as delta x by x is equal to delta a by a plus delta b by b. So whether you are multiplying or dividing doesn't matter. We have to calculate the maximum possible error. So that's why we will write the addition in between. Okay. And everybody got? Now, if I am saying x is equal to a to the power m, b to the power n, c to the power minus p. Now, here any power, maybe it is a fraction, maybe it is an integer, maybe positive integer, maybe negative integer. Then in that case, finding the error directly is very difficult. Finding the error is very difficult. But if you are going through the differentiation, like suppose x I am saying a to the power n. Then dx, what you can write? Dx you can write n a to the power n minus 1 into dA. After dividing dx by x, what you will get? N a to the power n minus 1 into dA upon a to the power n. Okay. Then how much? A n minus 1 here. So then a remaining. So dx by x, what you got? N dA by a. Okay. So basically what we will do in that case, directly we will multiply with power. So delta x by x. Differentiation everybody know. No need to differentiate in. If you are differentiating even, then also you will get the same result. Ultimately what I said, we have to calculate the maximum we have to calculate the maximum possible error. So directly after differentiating, I got the formula. By the differentiation, I have just shown the formula, what we are getting for the fractional error. Now after that, directly I am writing the result. Gyan Prakash. So to find the error, we will not differentiate. Why I differentiated? To show the formula, to prove the formula, how we got this formula, how we got the fractional error. That's why I differentiated. After that, in the error, we will not differentiate. We will directly remember the result. Okay. So then what we can say here, m, here power is m, then I will write m into delta a by a, plus what is the power here? N into delta b by b. And again, c power is negative. C power is negative. Basically, c I can say upon c to the power p. But whether it is a multiplication or a division, power positive or negative, we are always calculating maximum possible error. So that's why plus p into delta c by c. So this is the fractional error in x, delta x by x. Directly whatever the power is there, 1 by 2, 1 by 3, negative is there, but you will multiply with positive magnitude only. Okay, all error we will directly add. Completed. And then if they are asking the error, delta x, then what I will do? X, I will cross multiply. What is the x value? A to the power m, b to the power n, c to the power minus p. We will calculate. Okay. So just revise these formula and all, whatever I discuss, question I will discuss in the next class. Okay. And some more point I will discuss. Okay. Completed? Okay then. Okay then. Bye bye.